Hey guys and gals, today we're going to do another transformation, this time rotation. So here's how rotations work. We're actually going to take our original image, and what we're going to do with it is we're going to rotate it, all right? So we'll rotate it maybe 90 degrees or maybe 180 degrees. So we need to know a couple things. First, we need to know what direction. So if we're going to go counterclockwise, and we're always going to assume that left-hand turn counterclockwise, we need to know direction and how far. So are we going to go just 90 degrees? Or are we going to go 180 degrees? So we need to know direction and how far. The other thing we need to know is what point's going to remain stationary. If you've ever ridden on a carousel or a merry-go-round, one point in the center is always stationary. For us, that point will be the origin. So if I wanted to go, for example, say 90 degrees counterclockwise, it would look like this. If I wanted to go 180 degrees, then I would have to rotate it completely around like that. All right, obviously 360 would get you right back to your starting point, so those aren't very fun. But again, we need to know direction, so we're going to go counterclockwise, and we're always going to assume counterclockwise unless we're told otherwise. And then we also need to know what is that point that's going to stay still. So we're going to rotate about the origin for most of our work. So if I went 90 degrees counterclockwise around the origin, then my new image would end up looking something like that. All right, something like that. So it would rotate into this new position. Now, some people consider this to be one of the more difficult transformations to do. I'm going to show you the coordinate notation, and we're going to use that to do all of our drawings. For example, when we did reflections or translations, I taught you how to count. We're not going to count. We're only going to use coordinate notation with our work on this. It's going to make it easier, I promise. So let's get started. So on your notes page there, we've got our first image. I noticed that our original pre-image is here in quadrant 1, and we're asked to describe the transformation in words and in coordinate notation. So let's do it in words first. I noticed that it's in quadrant 1, and it looks like it's gone to the left, so that's counterclockwise. So I'm going to say we rotated counterclockwise. Got my W. Counterclockwise, and in this case, 90 degrees. Because notice, here's what it looks like. I'm going to rotate my page that direction, and what do you know? The black now looks like what it did. So cool. Clockwise, 90 degrees. Also notice, we went from quadrant 1 to quadrant 2. Anytime you switch an entire quadrant, that's a 90-degree turn. All right? So there's that. Let's talk about its coordinate notation. All right? Let's grab a point or two and see if we can't figure out what's happened. So let's grab H. H is at the coordinate 1, 3. So let's write that down. 1, 3. All right. H prime's new location is at -3, 1. So -3, 1. So let's write the coordinate notation out. How did we change from this to that? All right. So our original coordinates are x's and y's, whatever they are, we don't care. We transform or map onto this new spot and take a look. Notice that the the x rather, here on H was a 1. The y is a 1. So here's what happens. The x's and y's are going to trade places. This x coordinate, right, the first number, is now going to become the second number. See, this x, the 1, is now in the second position. Unchanged. It's still a positive 1. Now let's notice the y here was a 3. The first position here is that same 3, but it's been made opposite from positive to negative. So here's what happens. When we go counterclockwise, 90 degrees, the x's and y's trade positions. So instead of the x coming first, it goes last. And the y coordinate now is first and is opposite of what it was. All right, so we'll deal with that. We'll keep talking. All right, let's look at number 2. Number 2 is sort of odd. Notice we didn't change just one coordinate or one quadrant. We went 2. Take a look. G was here in quadrant 2, and it went through quadrant 3 and ended up in quadrant 4. So that's 2 quadrants it went through. If that happens, this is a rotation of 180 degrees. And notice, if you go 180 degrees, that's basically like turning yourself around. So if you're facing one direction and you turn yourself to face backwards, it doesn't matter if you go left or right. Notice if I go counterclockwise, 1, 2, we end up here. If I go clockwise, 1, 2 quadrants. we still end up in the same spot. So for 180-degree rotations, we really don't care about direction, whether we went to the left or if we went to the right. We end up in the exact same spot. Let's talk about the coordinate notation, though. So we start with x's and y's. Let's see what happened. Let's use g. G is at -2, 4. So -2, 4. G prime ended up down here at +2, -4. So +2, -4. Notice this 2 is still a 2. So the x's and y's don't trade positions like they did with the 90-degree. They stay in their current spots. So x and y stayed in the same positions. However, -2 to start, +2 to end. That's opposite. +4 to start, -4 to end. That's opposite. So for 180-degree rotations, we're going to take the original x's and y's and make them opposites of whatever they are. Remember, those negative signs that we see, we don't read them as negative. We read them as opposites when we're doing coordinate notation. So opposite of x, opposite of y. All right? And we'll do some of these, so this all makes sense. Just make sure you get it written down to start. Let's look at number 3. Number 3 is different. Take a look. Q is in quadrant 3, and it goes up here to quadrant 2. So it's only moved one spot. So that's a 90-degree turn. So let's write that in. We know it's going to rotate 90 degrees, but notice the direction. It wasn't going to the left. It's not this left-hand counterclockwise turn. It was a clockwise turn, a right-hand turn. So we say clockwise, 90 degrees. And let's look at the coordinate notation. How does that work? I'm going to use Q just because we've been talking about it. So Q, the original pre-image, is at -4, -3. So let's write that down. -4, -3. All right. Q prime is at -3. Oh, -3. There we go. +4. We'll take a look. The x's and y's traded places again. So let's write that down. So x's, y's in the original. In the final image coordinates, y comes first, x goes second. So let's look. Here's the original x. Notice it went opposite. -4 to a +4, so it went opposite. But notice the y, -3 here, and still a -3 there. So the y didn't change. So let's review this real quick. If we go counterclockwise, the x's and y's trade places. And notice counterclockwise, that's a left-hand turn. Notice our left-hand coordinate changed. It became opposite. If we've got a clockwise 90-degree turn, x's and y's still traded places, but clockwise is a right-hand turn. And notice the right-hand coordinate was made opposite. And again, we'll do more of these. It'll make more sense here in just a bit, I promise you. All right, this last one. Now, this last one looks an awful lot like a reflection, and I would agree with you. It certainly does. But I want you to notice something. If R was looking in the mirror, it should see R on the opposite side. And notice it doesn't. P looks in the mirror. It should see P, but it doesn't. So this is actually a rotation. If I take P and go up through 1, 2 quadrants, that's 180 degrees. If I take R and go through 1, 2 quadrants, that's 180 degrees. And even Q goes through 2 quadrants, 1, 2. So this is a 180-degree rotation. So rotation of 180 degrees. And then our coordinate notation is exactly the same as what it was in our last one. So x's and y's for 180-degree rotations do not change places. So in other words, the x's and the y's stay the same, but they do become opposites of whatever they were. And notice all of these, the y's would be negative because they're all lower than the x-axis, but up here they would all be positive, opposite of what they were. Here the x would be negative because it's on the left. Here the x would be positive because it's on the right. So again, x's and y's keep their same positions, but they become opposites of what they are. So let's use these coordinate notations to actually do the transformations, because with this, it's going to be a lot easier to use coordinate notation than it will be to count, I promise. All right? So let's take a look. We're going to graph the image of the figure using the transformation and then write the coordinate notations. So here we go. Let's start with coordinate notations. Rotation 90 degrees counterclockwise about the origin. Sometimes they'll say around the origin. So in other words, that point stays still right there. So 90 degrees, so I know that my x's and y's, whatever they are, if I'm going to go 90 degrees, have to trade spots. So the y will go first, the x will go second. And since it's counterclockwise, that's a left-hand turn, this side needs to become opposite, right? The left-hand side, right? Well, let's get our coordinates down, our originals, and then I'll show you how to make the new ones and how to do this. So we've got Hij, or GHij. Let's write that down, GHij. And again, we're going to use coordinate notation. We're not going to count. So G is at 1, negative 1. H is at 1, 0. I is at negative 3, negative 1. J is at negative 3, negative 4. All right. And I'm going to write my other coordinates down here. I don't want to get into that other spot there. So let's write all of our prime coordinates out. So we've got G, H, I, J prime. Now, first thing I'm going to do for each one of these is trade x's and y's. So the 1 and 1, well, that's not much different. So 1 and 1. Notice the y coordinate, so this one needs to be made opposite. So I'm going to make this a positive 1. All right, let's go down here. We need to trade places. So 0 goes first. The 1 goes second. And notice the y coordinate, so this needs to be made opposite. Well, 0 doesn't have an opposite, so it's just going to stay like that. Let's go to the next one. X's and y's need to trade positions. So negative 1, negative 3, all right? But notice the y, in this case the negative 1, has to be opposite. So instead of a negative 1, it's a positive 1. All right, and it's okay to write positive 1 like that. We're good. Let's do the next one. Negative 3, negative 4, negative 3. Because remember, we got to trade positions, so 3 goes last, 4 goes first. That y, so in this case the negative 4, has to become opposite. Positive 4, negative 3. Let's graph it. G is at 1, 1. So 1, 1. There it is, G prime. H is at 0, 1. H prime. I is at 1, negative 3. So that's down here. I prime. J is at 4, negative 3. So that's J prime. All right, let's play connect the dots. Notice 3 and 3, 1 and 1. All of the sides are the same size and in the same configuration, so these are congruent. All right, same size, same shape. If you end up with something that's not, then you've done it wrong. All right, let's do another one. Again, the more we do this, the easier it'll be. Rotation, 90 degrees, but notice this time it's clockwise. Let's get the coordinate notation done first. So x's and y's. All right, clockwise. So in this case, y still goes first, x still goes second, but clockwise is a right-hand turn. So it's this right-hand side that's going to be opposite. All right, let's get all of our coordinates written down, and then we'll send it through. So we've got u, v, w, and x. So let's write the coordinates down. U is at, let's see here, 4, negative 3. V is at 2, negative 2. W is at negative 1, negative 3. X is at 0, negative 5. Now, on this one, remember we did it each coordinate. We did G first, H second, and so on. If that bothers you, if that's too difficult to do, then let's try it a different way. All right, so let me show you 2 ways of doing this. So we got U, V, W, and X prime, okay? I'm going to do only one coordinate at a time. In other words, all the X's and then all the Y's, or vice versa. I notice that all of the Y's don't change in this case, so I'm going to start there. Here are all of the Y coordinates. Negative 3, negative 2, negative 3, negative 5. Those are the Y's to start. They're going to become the first coordinate, and they don't change. So I'm just simply going to copy them down. -3, -2, -3, -5. So here we go. -3, -2, -3, -5. I just took all the y's, copied them down because y's go first, and they don't change. They stay as they are. All right, let's go back. Let's do all the x's second. X's become opposites. So instead of +4, it's -4. Instead of 2, it's -2. Instead of -1, it's +1. And I'm going to write it like that just to remind myself. It's a +1. Now 0. 0 doesn't have an opposite. 0 is its own opposite. So there it is. Now let's graph it just to make certain that we've done it correctly and everything's going to end up in the right spot. So u prime is going to be at -3, -4. So here it is, u prime. So notice it shifted that right-hand direction 90 degrees. Looks good so far. -2, -2. So that's here for v prime. -3, +1. So -3, +1. Nope. Yeah, no, I did that, right? -3, +1. I did count up. I thought I counted down there for a second. So that's in the right spot. And then, oh, I've lost my place. -2, -2, -3, -4. Oh, I'm sorry. We're at W there. -3, 1. That's W prime. Okay. Helps if you can read. And then this last one here is -5, 0. Make sure I'm reading that right. -5, 0. Yep, right here. And that is, which one is that? That is X. X prime. Cool. So U and V connect. V and W connect. All right. W and X connect. There we go. And then last but not least, U and X connect. Excellent. So there it is. We've rotated it 90 degrees in that right-hand fashion. And again, just like I did, folks, if you, because I was getting confused there, reading wrong coordinates, take them one at a time, put them on there. And then if you want to play connect the dots as you go instead of at the end, you can do that as well. But be careful, slow down. This stuff is very easy to do, but also very, very easy to get wrong. All right, let's try another one. There we go. So rotating 90 degrees counterclockwise about the origin. Okay, we can do that. So X and Y counterclockwise. So, or excuse me, 90 degrees. Let's start there. So Y's and X's trade places. Since it's counterclockwise, that's a left-hand turn. That's the left-hand coordinate that's going to get altered. All right, so we'll do that. Let's get all of our coordinates written down, and then we'll start the graphing process. All right, so I need, let's see, I, J, K. So I, J, K. I is at -5, 2. J is at -2, 5. K is at -3, 0. Excellent. So we got all our coordinates. Let's get our prime coordinates out there, and then we'll start the graphing process. So I prime, J prime, K prime. All right. Let's do it like we did before. Let's do it one row of coordinates at a time. So let's do all the Y's first, just because they come first. So this tells us all the Y's need to be made opposite. So this 2, 5, and 0 need to be opposite. So I'm going to have -2, -5, and then of course 0 is its own opposite. All right. All the X's, so all these first coordinates are unchanged. Notice X here still looks like X here. So this is -5, -2, and -3. All right. Well, let's get them graphed. I is going to be at -2, -5. So that's all the way down here. So there's I prime. J is at -5, -2. So that's right here. And I'm not going to label it just because it's going to be kind of hard to see. K is at 0, -3. So that's all the way here. And that's K prime. All right, well, let's play connect the dots. And there it is. Same size, same shape. We know we've done it correctly. All right. Last one here of graphing, and then the next few we just have to get coordinates for. So all we can do is get coordinates for those, and we're home free. All right. So this one's 180, which is nice. 180-degree rotations are the easy ones to do. In this case, x's and y's stay in their same positions, so we still end up with x's and y's. The only difference, though, they become opposite of whatever they are. So 180-degree rotations are the easy ones. 90-degree rotations can be a pain. 180-degree rotations, they're not bad. So we've got, let's see, E, F, G. So let's get those coordinates. E is at -1, -2. F is at -1, 0. G is at -5, -3. So again, over 5, down 3. Looks good. Let's get our new coordinates drawn in. So we've got E, F, and G prime. And remember, all of these, the x's and y's stay in their same positions. They just become opposites. So in this case, instead of -1, it's a +1, +1, and then +5. All of them opposites. All right, let's go on the other side here. Opposite of -2 is +2. Opposite of 0 is itself. Opposite of -3 is 3. All right, all we got to do is graph those. So 1, 2, so over 1, up 2, that is for E prime. F is at 1, 0, so there's F prime. G is at 5, 3, so that's up here at G prime. And there it is, 180 degrees. And again, we don't care if it went to the right or the left. We don't care. 180 degrees, super, super simple. All right. Well, let's do these last two. I'm watching our time, and I know we're a little over on a typical video, but we'll be okay. Let's try these. So again, all we got to do is simply write out our new coordinates. We don't have to graph it. So up top here, it's taking us a little more time because not only do we have to get the coordinates, but we had to graph them. Here, we're not asked to graph. We're just asked to find the coordinates. Cool, we can do that. So let's get started. 90 degrees counterclockwise. Let's get the coordinate notation written in first. X, Y, and since it's 90 degrees, we're going to flip-flop them. So Y goes first, X goes second. And since it's counterclockwise, it's the left side, so the Y side that's going to be made opposite. All right, let's get all of our coordinates on there. So we've got I, J, and H. So I is at -2, -1. J is at -1, -5. And then H is at -3, -4. Now all we got to do is find our new coordinates. All right, so let's do that here. So we'll have I, J, and H prime. There we go. So let's start with the Y's. All of these here in the Y column are going to go first and be made opposite. So instead of -1, it's +1. Instead of -5, it's +5. Instead of -4, it's +4. All right. All the x's stay the same. So -2, -1, -3, they don't change. So -2, -1, -3, they all stay the same. Cool. And we would be done with that problem. That's all it required of us. Didn't ask to graph it, just asked for the coordinates. Cool. We're done. All right, let's try number 10. Number 10 is going to be just as easy, if not easier. Our coordinate notation for 180 is that we're going to keep those x's and y's in the same positions. So x is first and y is second. The only difference is we're going to make them opposites of whatever they were to start. So let's see here. We've got x, we got y, we got z. X is at -2, -2. Y is at 0, 3. Z is at -4, 1. All right. Let's grab our new coordinates. X, Y, and Z prime. And remember, the x's and y's are going to stay in their positions. They're just going to be opposites. So in this case, +2, 0, and +4. Because those are opposite, all right? Y's, same story, same position, just opposites. So +2, -3, -1. And there it is. We're done. And if you're ever unsure about these, we'll take them, plot them, and see if they end up in the right spot. If they do, then cool, you've done it right. If they end up kind of wonky, well, then you might double check, maybe you've misread something. All right, let's hit these last two. 90 degrees clockwise. Let's get our coordinate notation done in first. So we've got X and Y, and then, of course, our arrow here. 90 degrees clockwise. Well, that means that after we switch the X's and Y's, clockwise is a right-hand turn, so this right-hand coordinate becomes the opposite. So let's get them in here. We've got B, C, D, and E. B is at -1, -4. C is at 0, 1. D is at 3, 0. E is at 4, -3. Cool. Well, let's get our new coordinates. B, C, D, and E prime. Excellent. Y's go first. And notice Y's aren't changed. So this Y column, -4, 1, 0, and -3 aren't changed. They stay the same, just come first. So let's do that. So -4, 1, 0, and -3. All right. The X's become opposites. So opposite of -1 is +1. Opposite of 0 is 0. Opposite of 3 is -3. Opposite of 4 is -4. Cool. And there it is. We're done. All right, let's hit this last one and we'll call it a day. 90 degrees counterclockwise. So that's X's and Y's. Counterclockwise means that the left-hand side becomes opposite. Again, 90 degrees means X's and Y's trade places. Counterclockwise, left-hand turn, so left-hand side becomes opposite. Wonderful. All right, well, let's see what we can do here. Oh, wrong pen. Here we go. So B, C, D again. So let's do it this side. B, C, and D. B is at -3, -4. C is at -1, 1. D is at -1, -3. All right. All we need to do then is find those new coordinates. Pretty simple. So B prime, C prime, D prime. All right, well, let's start off. All the Y's need to be made opposite. So the Y's are in the second column. So -4 becomes +4. +1 becomes -1. -3 becomes +3. I'm going to write that in so we can see it. All right. Let's try the X's. X's don't change, but they get written in the second position now. So -3, -1, -1. Excellent. And we're done. So of all of our transformations, these are the ones that cause the most grief. Please make sure that you bring your questions with you today to class. I do not want you to feel like that you are lost or that you can't do it. All right, we'll talk about them today. Enjoy it.